Out in the depths of the universe, galaxies drift through space like glowing cities made of stars. Each one contains billions, sometimes trillions, of suns bound together by gravity. They seem peaceful from afar, slowly spinning in the darkness of the cosmos. But every so often, something extraordinary happens. Two galaxies begin moving toward each other across the vastness of space. Their spiral arms stretch, stars shift into new paths, and immense rivers of gas ignite with newborn suns. Over millions of years, these gigantic systems collide and merge, and when they do, the entire structure of the cosmos changes. But this raises a profound question. Why do galaxies collide at all? What invisible force guides objects so enormous across distances so unimaginable? And what does this cosmic dance reveal about the history of the universe itself? In this journey, we'll travel from the smallest particles of matter to the largest structures in existence. We'll uncover how gravity quietly shapes galaxies, how collisions create new stars, and why our own galaxy is destined for a dramatic encounter billions of years in the future. By the end, the universe may look very different than it did before. Out in the vast darkness of space, galaxies drift like luminous islands in an endless cosmic ocean. Each one contains billions, sometimes trillions of stars bound together by gravity. From afar they appear calm and majestic, slowly turning through the universe. Yet sometimes these enormous structures begin moving toward each other. At first, the motion is almost imperceptible. Two galaxies separated by hundreds of thousands of light years slowly change their paths. Like distant dancers noticing one another across a ballroom floor, their trajectories subtly shift. Gravity begins to whisper between them across unimaginable distances. The idea can feel strange at first. Galaxies are so vast that it's easy to imagine them as permanent fixtures of the universe. But space is not a frozen stage. It's more like a slow cosmic river where everything moves. And within that river, galaxies can drift closer and closer over billions of years. To picture this, imagine two swirling hurricanes in the atmosphere. At first, they spin independently, each following its own path. But if their winds begin interacting, their movements start to change. Eventually, they may spiral toward one another in a dramatic encounter. So the question begins to unfold. Why do these gigantic systems, each containing billions of stars, ever meet at all? What invisible forces guide galaxies across such enormous distances? Before answering that, astronomers first had to discover something surprising about the universe itself. Galaxies collide far more often than anyone once believed. When astronomers first began mapping the universe with powerful telescopes, they noticed something unexpected. Some galaxies didn't look smooth or symmetrical at all. Instead, they appeared stretched, twisted, or tangled together like strands of glowing cosmic taffy. These strange shapes were the first clues that galaxies sometimes interact in dramatic ways. In deep space images, long streams of stars can be seen flowing between neighboring galaxies. These glowing bridges, called tidal tails, stretch across hundreds of thousands of light years. They look almost like luminous rivers pulled from one galaxy toward another. Gravity is gently tugging on entire star systems, reshaping galaxies as they pass. Sometimes the evidence is even more striking. Two spiral galaxies may appear to overlap, their arms tangled like spinning pinwheels caught in the same wind. Gas clouds crash together, stars shift into new orbits, and the galaxies begin a slow, graceful merger. Over time, their original shapes fade as they form a completely new galaxy. One famous example shows two galaxies locked in a dramatic embrace, their spiral arms warped and stretched. To observers on Earth, it looks like a snapshot of a cosmic collision frozen in time. But in reality, this event unfolds over hundreds of millions of years. It's less like a crash and more like an enormous gravitational dance. As astronomers continued observing the sky, they realized these encounters aren't rare accidents. Across the universe, galaxies are constantly interacting, pulling on each other and merging. This revealed something profound. Galaxies are not isolated islands after all. To understand why these encounters happen, scientists had to look deeper, far deeper, into the smallest building blocks of matter itself. To understand why galaxies move the way they do, scientists often begin at the smallest possible scale. Every star, every cloud of gas, and every grain of cosmic dust is built from atoms. And those atoms themselves are made of even smaller particles interacting through fundamental forces. In many ways, the story of galaxies begins with the physics of the tiniest pieces of matter. At the atomic level, forces like electromagnetism dominate the scene. Electrons swirl around atomic nuclei, much like tiny planets orbiting a star. These interactions determine how atoms bond together to form molecules, rocks, oceans, and even living things. But gravity, the force that rules galaxies, is almost invisible at this microscopic scale. Compared to other forces, gravity is astonishingly weak between individual particles. Two atoms barely feel each other's gravitational pull at all. It's like two grains of sand trying to tug on each other across a beach. On the smallest scales, gravity seems almost irrelevant. But something remarkable happens as matter begins to gather. Add enough particles together, trillions upon trillions, and gravity starts to add up. What was once insignificant becomes a quiet but relentless force. Little by little, gravity begins shaping larger and larger structures. This is one of the universe's most fascinating secrets. The weakest force in the microscopic world becomes the dominant architect of the cosmos. From tiny particles to stars and galaxies, gravity slowly takes control of the grand design. And the next step in this story appears much closer to home, in the graceful motion of planets and moons. To see gravity in action more clearly, there's no need to look across billions of light years. The same force quietly shaping galaxies is also guiding the motion of worlds in our own cosmic neighborhood. Every planet, moon, and comet in a solar system is part of a delicate gravitational balance. And that balance creates the graceful orbits we observe in the night sky. Take Earth and the Sun, for example. Our planet is constantly falling toward the Sun due to gravity. But because Earth is also moving sideways through space, it never crashes inward. Instead, it keeps missing the Sun, tracing a smooth orbit year after year. It's a bit like swinging a ball on the end of a string. The tension in the string pulls the ball inward while its motion carries it forward. The result is a circular path that repeats over and over. Gravity works in a similar way, but without any physical string holding things together. Moons follow the same principle around their planets. Jupiter's dozens of moons circle their giant host in an intricate gravitational ballet. Each body pulls on the others ever so slightly, nudging their paths over time. These gentle interactions can slowly reshape entire systems. What's fascinating is that the same rules apply everywhere in the universe. From moons orbiting planets to stars orbiting galactic centers, gravity connects it all. The patterns we see nearby echo on much larger cosmic stages, and scientists have found clever ways to observe these patterns when galaxies themselves begin to interact. To understand something as vast as colliding galaxies, astronomers can't simply wait and watch the entire event unfold. These encounters take hundreds of millions, sometimes billions of years to complete. So instead, scientists piece together the story using snapshots from across the universe. Each galaxy we observe reveals a different moment in this enormous cosmic process. Some telescopes capture galaxies just beginning to interact, their spiral arms stretched slightly, as if gently pulled by an invisible hand. Others show galaxies mid-encounter, their shapes twisted into spectacular arcs and glowing streams. And a few reveal the aftermath, two galaxies already merged into a single new structure. Modern observatories allow astronomers to study these interactions in remarkable detail. Instruments sensitive to visible light, radio waves, and infrared radiation reveal different pieces of the puzzle. Gas clouds glowing in infrared light show where new stars are forming. Meanwhile, radio observations trace enormous rivers of hydrogen stretching between galaxies. But observing alone isn't enough to understand the full story. This is where computer simulations come in. Using powerful supercomputers, scientists recreate galaxies using millions of digital particles. Then they allow gravity to guide their motion, watching entire galactic encounters unfold in virtual space. These simulations reveal something extraordinary. When two galaxies pass near each other, their gravity stretches and distorts their shapes in predictable ways. Like two whirlpools interacting in a vast ocean, their motions begin to intertwine. And at the heart of these encounters lies the same force that governs planets, stars, and entire galaxies: gravity itself. At the heart of every galactic encounter lies a force that operates quietly but relentlessly across the universe. Gravity doesn't shout or explode with sudden power. Instead, it works slowly, patiently pulling objects toward one another across immense distances. And when galaxies travel through space, this gentle attraction begins shaping their paths. Imagine two ice skaters gliding across a frozen lake. At first they move independently, each following their own direction. But if they grab hands, even lightly, their motion changes instantly. They begin circling each other, drawn into a shared dance. Galaxies behave in a surprisingly similar way. Each one carries enormous mass, billions of stars, clouds of gas, and vast halos of invisible matter. That mass creates a powerful gravitational field extending far beyond the visible galaxy itself. When two galaxies drift close enough, those invisible fields begin to overlap. Once that happens, their motions slowly begin to change. Gravity pulls stars, gas, and dark matter toward new trajectories. The galaxies may swing past each other once, then again, each pass tightening their gravitational bond. Over time, their separate identities start to blur. Eventually, the two galaxies spiral inward and merge into one larger system. It's not a sudden crash, but a slow cosmic embrace unfolding over millions of years. Gravity, the quiet architect of the universe, has once again reshaped the structure of space. And in the process, these encounters can ignite one of the most spectacular events in astronomy, an explosion of newborn stars. When galaxies begin to interact, something remarkable can happen inside their vast clouds of gas and dust. The gravitational tug between the galaxies squeezes enormous regions of interstellar material. Gas that once drifted quietly through space suddenly becomes compressed and unstable, and under the pressure of gravity, new stars begin to ignite. These events are known as starbursts. In certain regions of colliding galaxies, stars can form hundreds of times faster than normal. Imagine squeezing a giant cloud until parts of it collapse inward, like droplets forming in a storm cloud. Each collapsing pocket becomes the seed of a brand new star. Around many of these newborn stars, swirling disks of gas and dust begin to form. Inside these spinning disks, particles collide, stick together, and slowly grow larger. Tiny grains become pebbles, pebbles become rocks, and rocks eventually grow into planets. It's a process not so different from snowballs forming as snow gathers and sticks together. Our own solar system likely formed in a similar environment long ago. About 4.6 billion years ago, a cloud of gas collapsed and gave birth to the Sun. Around it, the remaining material flattened into a rotating disk that formed the planets. Events happening across distant galaxies today may be creating countless planetary systems just like ours. So galaxy collisions are not merely destructive encounters. They are also powerful engines of creation, triggering waves of new stars across the cosmos. Entire generations of suns and perhaps worlds can be born from these dramatic events. And that raises an intriguing question. If galaxies collide, what would such an event mean for a small planet like Earth? Hearing that galaxies collide can sound terrifying at first. After all, if two enormous systems of billions of stars crash together, wouldn't everything inside them be destroyed? It's easy to imagine stars smashing into each other like cosmic billiard balls. But the reality of galactic collisions is far stranger and far gentler than that. The reason lies in the immense emptiness between stars. Even inside a galaxy, stars are separated by staggering distances. If the Sun were the size of a tennis ball, the nearest star would still be thousands of kilometers away. Space inside galaxies is mostly empty, like grains of sand scattered across an entire continent. Because of this vast spacing, when galaxies merge, most stars simply pass by each other. Their paths may bend slightly as gravity reshapes their orbits, but direct collisions between stars are extremely rare. In most cases, stars continue traveling through space almost untouched. If our own galaxy were to collide with another, Earth would likely survive the encounter. The Sun would keep shining, and our planet would probably remain in orbit around it. What would change is the night sky itself. Brilliant streams of stars and glowing clouds of gas might stretch across the heavens. Astronomers actually know that such an event is coming someday. The Milky Way is slowly drifting toward its large neighbor, the Andromeda Galaxy. Billions of years from now, these two galaxies will begin their slow gravitational dance. To understand what that future might look like, we need to zoom out even further, to the scale of entire galaxies evolving across the universe. When astronomers study the universe across billions of light years, a clear pattern begins to emerge. Galaxies are not static monuments frozen in space. They grow, change, and evolve over immense stretches of time. And one of the main engines behind that evolution is the slow merging of galaxies. In the early stages of a collision, spiral arms stretch and warp like taffy, being gently pulled apart. Stars drift into new orbits, while enormous rivers of gas flow between the galaxies. Over time, the elegant spiral patterns begin to fade. The once separate galaxies gradually blend into a single, larger system. The final result often looks very different from the galaxies that started the encounter. Many mergers produce giant elliptical galaxies, massive, rounded collections of stars. It's a bit like mixing two spinning storms until their original patterns disappear. What remains is a calmer but far larger structure. This process has happened countless times throughout cosmic history. Small galaxies frequently merge with larger ones, adding their stars to an expanding system. Like droplets of water gathering into a growing river, galaxies build themselves through repeated encounters. Bit by bit, the universe constructs its grandest structures. Our own galaxy carries the evidence of this ancient history. The Milky Way has absorbed many smaller galaxies over billions of years. Faint streams of stars still drift through our galaxy as silent reminders of those past mergers. And to understand how this process began, scientists must look back to the earliest chapters of the universe itself. To truly understand why galaxies collide, astronomers have to rewind the story of the universe to its earliest moments. Shortly after the Big Bang, the cosmos was a hot, dense sea of particles. Matter had not yet formed stars or galaxies. Instead, tiny fluctuations in density rippled through the expanding universe. These small irregularities were like gentle wrinkles in an otherwise smooth fabric. Some regions contained slightly more matter than others. And because gravity pulls matter toward matter, those denser regions began attracting more material. Over millions of years, these areas slowly grew larger and heavier. Eventually, the first small galaxies began to form. They were far smaller than the giant galaxies we see today. Imagine scattered snowballs beginning to roll across a snowy field. As they gather more snow, they grow bigger and begin to interact with one another. Gravity then continued its quiet work across billions of years. Small galaxies drifted toward one another and merged again and again. Each encounter built larger and more complex galaxies. Through this cosmic accumulation, the grand structures of the universe slowly took shape. So the collisions we observe today are part of a much older story. They are echoes of the same gravitational process that built galaxies in the first place. The universe has been assembling itself piece by piece since its earliest moments. And when we step back and reflect on this immense cosmic construction, a deeper perspective begins to emerge about our place within it. When we step back and look at the universe on its largest scales, a quiet realization begins to emerge. Galaxies, those immense islands of stars, are not permanent structures. They move, interact, merge, and transform over billions of years. The universe is not static. It is constantly evolving. A galaxy collision might sound violent, but in reality it is more like a slow cosmic dance. Two vast spirals drift toward one another, their arms stretching like luminous ribbons. Stars glide through space, their paths gently reshaped by gravity's pull. Over time, the galaxies blend into a completely new creation. These encounters remind us that the cosmos is shaped by patience. Gravity works slowly, almost invisibly, yet it can transform entire galaxies. What seems permanent today may look completely different billions of years from now. The universe is always in the process of becoming something new, and somewhere within one quiet spiral arm of the Milky Way, a small blue planet circles an ordinary star. On that planet, a curious species has learned to look up at the night sky. They build telescopes, observe distant galaxies, and uncover the story of these immense encounters. In doing so, humanity becomes a witness to the universe's grand and ancient dance. Galactic collisions remind us of something profound. Even the largest structures in existence are part of an unfolding cosmic journey. Across unimaginable distances and timescales, gravity choreographs the motion of galaxies. And from our tiny corner of the cosmos, we watch this vast story slowly reveal itself.